In today's video, we dive into the critical question: is it climate change, or just normal weather cycles? As we explore this complex topic, we'll examine historical climate variability and how human activity is influencing the planet's climate at an unprecedented rate. We'll also discuss rising carbon dioxide levels, the frequency of extreme weather events, and the natural drivers behind weather cycles. With insights from temperature reconstructions and the scientific consensus on climate attribution, we aim to clarify the distinction between short-term trends and long-term climate changes, while addressing public perceptions and media narratives surrounding this vital issue. 1. Historical climate variability. The Earth has undergone natural climate fluctuations for millions of years, including ice ages and warm interglacial periods. These cycles are driven by factors like Milankovitch cycles, which involve changes in Earth's orbit and tilt. Volcanic activity also plays a role, spewing particles into the atmosphere that can cool the planet. For instance, the eruption of Mount Tambora in 1815 led to the year without a summer. These natural patterns provide a baseline for understanding human impact. However, the current changes seen today appear to deviate significantly from these historical norms, suggesting other forces at play. 2. Anthropogenic influence on climate. Since the Industrial Revolution, human activities have significantly impacted Earth's climate. The burning of fossil fuels, deforestation, and industrial agriculture have increased greenhouse gas concentrations in the atmosphere. These activities amplify the natural greenhouse effect, trapping more heat and causing temperatures to rise. Unlike natural cycles, which can span thousands of years, the human influence on climate is evident over just a few decades. This rapid change is troubling because it doesn't give ecosystems and species time to adapt. Consequently, the rate of change is a key factor distinguishing human impact from natural cycles. 3. Rate of current changes. Natural weather cycles often occur over centuries or even millennia. However, the current rate of temperature rise is unprecedented in Earth's history. This rapid warming is strongly correlated with human activities, particularly the emission of greenhouse gases. It's akin to a car suddenly accelerating without any apparent reason. Scientists have observed that many species and ecosystems cannot adjust quickly enough to these rapid changes. This quickening pace raises concerns about biodiversity loss and the ability of natural systems to provide ecosystem services essential for human survival. 4. Carbon dioxide levels. Atmospheric carbon dioxide, CO2, levels have reached over 420 parts per million, ppm, the highest in at least 800,000 years. This spike in CO2 levels cannot be explained by natural cycles alone. The increase aligns closely with the timeline of fossil fuel combustion, particularly since the Industrial Revolution. Imagine a bathtub slowly filling with water. Now picture a faucet suddenly turned on full blast. The water level rises much faster, just like CO2 levels due to human activities. This dramatic increase is a primary driver of the warming trend observed today. 5. Extreme weather events. Extreme weather events, like hurricanes and droughts, have always been part of Earth's climate system. However, there's growing evidence that climate change increases their intensity and frequency. For example, warmer ocean temperatures provide more energy for hurricanes, making them more destructive. It's as if someone added extra fuel to a fire, causing it to burn more fiercely. These changes have significant implications for human societies, affecting everything from agriculture to infrastructure. Understanding this link helps explain why we see more extreme weather events today compared to the past. 6. Natural drivers of weather cycles. Factors like El Niño and La Niña, which are Pacific Ocean temperature oscillations, significantly influence short-term weather patterns. Similarly, the North Atlantic Oscillation, NOW, affects weather in the Northern Hemisphere. These cycles create variability that can mask long-term trends, much like short-term fluctuations in a stock market. While they can explain specific weather events, they do not account for the persistent trend of rising global temperatures. Recognizing the distinction between these natural cycles and long-term climate change is crucial for informed policy and action. 7. Temperature reconstructions from the past. Scientists use ice cores, tree rings, and sediment data to reconstruct past climate changes. These records show that current warming trends exceed those observed in previous natural warming events, both in magnitude and pace. It's like comparing a gentle slope to a steep hill. Today's changes are far more rapid and pronounced. Such reconstructions provide valuable context for understanding the unprecedented nature of current climate change. They also help validate climate models that predict future warming, underscoring the importance of reducing greenhouse gas emissions. 8. Misinterpretation of short-term trends. Critics often point to short-term cooling or unusually cold winters as evidence against climate change. However, these fluctuations are normal and occur within the broader context of long-term warming. It's similar to experiencing a cold day in summer, it doesn't negate the overall season. Climate scientists emphasize the importance of looking at long-term trends rather than isolated events. This perspective helps counter misconceptions and highlights the pressing need for action to address the underlying causes of climate change. 9. Scientific consensus on attribution. Climate models and attribution studies demonstrate that observed warming since the mid-20th century cannot be explained without accounting for human activities. Even when natural variability is included, the human influence remains dominant. These models are like complex equations that balance various factors to explain observed phenomena. The scientific consensus is clear: human activities are driving the current warming trend. This understanding is critical for developing effective strategies to mitigate climate change and adapt to its impacts. 10. Public perception and media coverage. Confusion often arises when media oversimplifies climate science, leading some to believe that every weather event is a direct result of climate change. This misrepresentation fuels skepticism and polarizes the debate. It's akin to judging a book by its cover without understanding the story inside. Effective communication of climate science is essential for building public understanding and support for necessary actions. Bridging the gap between scientific complexity and public perception is a key challenge for policymakers and communicators alike. Understanding the distinction between natural variability and anthropogenic influence is essential for informed discussions and effective action. Acknowledging the complex interplay of factors allows us to address the challenges of climate change more comprehensively.